So first we want to go ahead and explore how to expand the sum in sigma notation. So to expand the sum in sigma notation, we want to write out the sum with one term for each value of k. We're then going to go ahead and combine all the terms to find the exact value of the sum. And so to warm us up, let's think about two examples here. The first example that we're going to consider is to find the exact value of the sum from k is 1 to 2 of 72k, all divided by k plus 7. And the second example, let's think about where we have the sum from k is 1 to 4 of negative 1 to the k, multiplied by cosine of k pi. So if you want, take a minute and pause the video here and try these problems on your own. And then you can look at the solution together with me after. Here we go. Example 1. Find or write the sum without the sigma notation and then evaluate to find the value of the sum. So the first thing that we want to do again is to simply write the sum without our sigma notation. So we want to expand this out. Again, we have the sum from k is 1 to 2 of 72k, and that's all divided by k plus 7. So to expand this out, we start with our lower limit here. K is 1, and go all the way up to k is 2. So first things first, we have 72 multiplied by 1, and that's all divided by 1 plus 7. And then this is going to be plus 72 multiplied by 2, all divided by 2 plus 7. And we call this the expansion. And all we've done is expand the sum. We haven't evaluated, we're simply expanding. So there's our expansion. So now using this expansion, we want to find the exact value. So let's simplify. We have 72 times 1 is 72, divided by 1 plus 7 is 8, plus 72 times 2 leaves us with 144, all divided by 2 plus 7 is 9. And so we're lucky here. We can simplify. We know that 8 goes into 72 9 times, and we also know that 9 goes into 144 16 times. So we have this is equal to 9 plus 16, which leaves us with that beautiful final answer of 4. And so this is the exact value of the sum and our final answer. Example number 2. Write the sum without sigma notation and then evaluate to find the exact value of the sum. And so the first thing we want to do is simply find the expansion. So expand this out, starting with your lower limit of summation, k is 2, and then at each k until we get to 4. So let's go right for this. So when k is 1, this is equal to negative 1 to the first, multiplied by cosine of 1 times pi, plus negative 1 squared, multiplied by cosine of 2 times pi, plus negative 1 cubed, multiplied by cosine of 3 times pi. And then last but not least, we have plus negative 1 to the fourth, multiplied by cosine of 4 times pi. So here is our expansion. We've simply plugged each term in their index of summation into our general formula, and now we're ready to start simplifying. So looking at these alternating portions here, we know that any time a negative value is raised to an odd number, it leaves us with an odd number. So these negative 1 to the first is going to minus 1. Negative 1 cubed is going to leave us with minus 1. Versus when we have a negative value raised to an even degree, it remains or becomes positive. So this is leaving us with, we have minus cosine of pi plus cosine of 2 pi minus cosine of 3 pi plus cosine of 4 pi. And so now we want to evaluate our trig functions. All right, so we know cosine of pi goes to -1, cosine of 2 pi goes to 1, cosine of 3 pi goes to -1, and cosine of 4 goes to +1. And so simplifying, we have negative times a negative, which is +1, plus 1. Again, negative times a negative gives us +1, plus 1. And so the exact value of this sum, our beautiful final answer, is 4.